Data is big, but its potential is even bigger. When combined with analytics and AI, data holds the promise of curing diseases, saving lives, reversing climate change, and changing the way we live. We believe the future depends on data and unlocking its limitless potential. We're here to make that happen. Databricks is the lakehouse company. We help data teams, engineers, analysts, and scientists work together to find value inside data and solve the world's toughest problems. Because the challenges we face as businesses, as people, and as a planet aren't easy. They can't be solved in silos. They can't be solved by one person. We need all the data, all the science, all the brain power. We need all hands on deck in one place, on the only open, unified platform for data management, business analytics, and machine learning. And that changes everything. It expands our sense of what's possible. It makes things simple. It turns weeks into minutes so data teams can innovate faster, because that's how innovation should happen, collaborative and fast. So let's defy assumptions, break the mold, map every genome, cure every cancer, binge watch the cosmos, spelunk black holes, make every voice heard, reverse global, unlock take more moonshots and land them.
The heavens have become a part of man's world.
From now on, nothing stands between you and your data, you and the answers, because the power of data is the power of knowing. Now, you know.
네, 안녕하세요. 데이터브릭스 솔루션 아키텍트 팀의 장경훈입니다. 저희 버추얼 이벤트 다시보기 프로그램으로 오래간만에 다시 인사드립니다. 오늘은 AI 시대의 데이터 웨어하우스라는 제목으로 컨텐츠를 준비해봤습니다. 아마 여러분들도 최근에 매일 생활 속에서 체감을 하고 계실 것 같은데요. 요즘 산업의 거의 전 분야에서 AI 적용이 활발하게 시도되고 있는 것 같습니다. 오늘의 주제인 전통적인 분석계 데이터 플랫폼이라고 할 수 있는 데이터 웨어하우스 시장에서도 AI를 적용해서 더 나은 성능과 편의성을 제공하려는 시도가 이어지고 있고요. 이 변화를 데이터브릭스가 주도하고 있습니다. 오늘은 짧은 3개의 발표를 준비했는데요. 첫 번째는 키노트 세션이고요. 저희 코파운더 중에 한 명인 레이놀드의 발표를 보실 예정입니다. 레이크하우스라는 개념을 먼저 간단하게 소개를 해드리고요. 여기에 더해서 데이터브릭스가 AI 기법을 활용해서 데이터 웨어하우스를 어떻게 진일보시키고 있는지를 설명드릴 예정입니다. 두 번째 발표는 저희 본사의 프로덕트 매니저 중에 한 명인 알렉스라는 분이 발표를 해주실 텐데요. 자연어를 활용해서 SQL 개발을 더 쉽게 하고 생산성을 향상시킬 수 있는 데이터브릭스의 자연어 인터페이스에 대해서 소개해드리고 데모도 보여드릴 예정입니다. 그리고 마지막 발표에서는 데이터브릭스의 데이터 레이어, 쿼리 엔진, 컴퓨트 레이어 이렇게 각각의 기술 레이어에 내재되어 있는 AI 기법들이 어떻게 성능 향상과 비용 절감에 기여할 수 있는지에 대해서 설명을 드릴 예정입니다. 모쪼록 유익한 시간이 되시기를 바랍니다.
Hello, and welcome to the virtual event for data warehousing in the era of AI. I'm Kevin Klugage, product marketing for data warehousing and Databricks SQL, and your host for today. Thank you for joining. This is an exciting time for anyone that works with a data warehouse, whether you manage it, build data pipelines, analyze the data, or build reports, whatever it might be. AI and generative AI in particular have given us new capabilities to address what we see as the biggest challenges with data warehouses today. A lot of the fundamentals of how data warehouses operate and how people use them are changing right now. We have a great lineup. Feel free to ask questions during the event as we have our team here to help answer as many of them as possible. And to kick us off and share his thoughts on this topic for our opening keynote, I'd like to welcome our co-founder and chief architect of Databricks, Reynolds Shin.
Thank you, Kevin. I'm super excited to be here today to be talking to you about data warehousing in the era of AI. It's a problem I've been thinking about a lot personally and professionally for the last few years. And Databricks SQL, in a way, is the result of that. So very excited to be talking to you about it. AI is changing everything. I believe all you believe that now after November 2022, and this really also includes data warehousing. But one of the biggest challenges for customers to leverage AI with their data warehouses is that the enterprise data architecture and AI architecture are fundamentally fragmented. In virtually every organization, they would have one or more data warehouses for the business intelligence workload. They're all about looking into the past of what has happened. And they will have one or multiple data lakes for looking into the future for the artificial intelligence workloads. And these two are fundamentally disparate platforms that don't really coexist with each other. They don't talk to each other. It's very difficult to replicate data. It's very difficult to actually govern the data. But both data workloads and BI workloads and the AI workloads have one thing in common, which is the data they need. So about 4 years ago, Databricks pioneered the concept of lakehouse architecture. And the idea of the lakehouse architecture is very, very simple. The lakehouse combines the best of data warehousing and data lakes. So you can actually do both BI and AI, or data and AI, on one platform. And today, according to MIT Technology Review insights, 74% of global enterprises have adopted lakehouses. The lakehouse is really the foundation that we build Databricks SQL on top of. And at the very core of the lakehouse is the open data lake that you can store all of your data in. And this includes your structured data to represent your BI workloads, your data warehousing workloads, as well as a lot of unstructured data. And there's a central catalog called Unity Catalog on top of Databricks that provides unified security, governance, and cataloging on all of this data. And building on top of the storage and the catalog governance layer, we built different product lines for different set of applications. And this includes Mosaic AI for data science and AI, DLT, Delta Live Tables for ETL and real-time analytics, workflows for orchestration, and last but not least, Databricks SQL for data warehousing. And we say the best data warehouse is a lakehouse. And this is because by building on top of a lakehouse, Databricks SQL, the data warehouse, now cuts out the data silos. There's no more data copying. There's no more synchronization of permissions. There's no more data sort of leakage because you forgot to apply a policy in one platform versus another. It provides truly the unified foundation to that. Now, the data intelligence engine, what we call Databricks IQ, builds on top of the lakehouse foundation and applies to virtually every single component in the lakehouse. And we can use generative AI to now understand the semantics and the structure of data to optimize everything. And there are three most important pillars when we talk about optimizing everything in providing the intelligent data warehouse. The first is by providing intelligent experience with natural language. So we can now enable everybody to access and ask questions about data. The second is applying the AI capabilities to provide predictive optimizations for your infrastructure. So now you can save your team valuable time and resources from having to apply those optimizations yourself. Why not have AI do the job for you? And through that, we can provide world-class price performance and result in the best TCO or total cost of ownership in the market. So the first component of that is natural language. And Andre Kapasi was famously quoted a few years ago for saying the hottest new programming language is English. What that really means is English or natural language can become the API now for programming all of this data and AI systems. And you're all seeing a lot of demos in maybe the last decade from various vendors that show you, hey, here's you can type in a natural language question and the system will spit out some results for you that was correct. Now, unfortunately, most of those efforts remain in demoware stage. And the reason is it's actually incredibly difficult to build a general purpose system that will really understand your data and can answer all kinds of questions about the data. And that's why we spent so much time and resource building Databricks IQ, the intelligence engine, to really understand the structure and the semantics of our data. And leveraging that, we can actually provide much better sort of results. And this is no longer just a demoware. As a matter of fact, about half of Databricks users every day are using the Databricks IQ provided powered sort of intelligence authoring interfaces, such as a SQL editor, as well as building the Lakeview dashboards. Alex will be diving more into this topic in later. The second part and the third part is really about performance and cost. And so much of data warehousing is really built on that. As a matter of fact, the whole field of data warehousing really started when Ed Codd in 1970 wrote his seminal paper titled A Relational Model of Data for Large Shared Data Banks. And in this paper, the very first sentence of the paper is the future users of large data banks must be protected from having to know how the data stored organized in the machine. And what this really referring to is, regardless of how the data is structured and organized under the hood, users shouldn't care, because the system will be smart enough to optimize it to provide the best performance, regardless of data in it. Now, reality is obviously this hasn't been true. All of you, or so all your team members, people reporting you, probably have spent a significant amount of time actually creating indexes, deciding what columns to cluster, doing compactions in the databases to ensure good performance. So how can AI help here? Think about it. This is really one of the perfect prompts for AI. How do we automatically optimize a system so we can guarantee the best performance, and the end users don't have to care about it? The reason I say this is a perfect prompt for AI is because of the following three reasons. One is we have collected a huge amount of query patterns over the years, because mankind has run a lot of queries. So there's a lot of training corpus. The workloads are fairly complex, because there are all kinds of workloads running on top of data warehouses, and they're very difficult to model by heuristics. And last but not least, the workloads tend not to dramatically change very quickly. They might actually still change as you bring on building new applications and business use cases, but they tend to not change within a second or two and have a massive, for example, spike. So we embark on this journey of leveraging, thinking about how do we leverage AI to improve, to mitigate and solve this problem. And we collected the most diverse workload from billions of containers, trillions of queries, and zettabytes of data. And through it, we built AI directly into an engine. So it's not just a bolt-on. And the engine has been fundamentally changed to emit way more telemetry than before. So they can feed into Databricks IQ to train sophisticated machine learning models for each of the workloads. And these models are then applied in real time as predictive optimizations to aid the engine in making decisions during query processing. Through all this, we're able to accomplish world-class performance and having the lowest total cost of ownership will meet or beat pretty much every other data warehouse in price and performance across all scale factors. And we're just getting started. But some of you might wonder, hey, obviously I care about price performance, but I also care about really great predictive low latency. I can't just have a system that's super cheap, but then it takes a very long time to return queries, because I have a lot of users that are interactively analyzing data. Using AI, we also can accomplish world-class performance for the interactive BI queries. Here's a benchmark that shows Databricks scale on the real workloads from 2 users all the way to 512, and keeping a constant, stable, low latency on the query result. Whereas a leading multi-cloud data warehouse would degrade performance to the point that actually becomes 9 times worse. So Databricks SQL is 9 times better in this specific case at scale, at concurrency, than the leading cloud data warehouse. And at Eventa, a customer have observed that when they converted over their analysts to rely on Databricks SQL for BI, they have accomplished 30% better performance and reduced costs by 20% on average. This is across the board. So this is all part of Databricks SQL, our data warehouse offering built on top of the data intelligence platform. Now, for the rest of the day, we'll be getting into each of the areas in more detail. Now back to you, Kevin.
Great. Thank you, Reynold. The research and work from your engineering team is really reinventing major areas of the data warehouse. There's a lot of innovation happening in this space, and there's definitely more to come. Next, then, I'd like to introduce Alex from our product team, who will open up the world of natural language interfaces with data warehousing, or as we like to call it, the sequel to SQL. With that, over to you, Alex.
All right. Thank you, Kevin. Super excited to be here. My name is Alex, and I'm a senior product manager at Databricks. Today, I'm really excited to walk through Databricks SQL and show you how new natural language interfaces are making it really easy for anyone to get insights from your data. So up till now, gathering insights from your data really required some pretty deep technical know-how. You would have to understand the intricate web of tables that exists in your data environment, and that's not always easy. With AI, non-technical users are now better equipped to understand your data and be able to use natural language interfaces to query them. Previously, often you'd have data teams that are scrambling to answer questions from the business, but now we're seeing a shift to self-service platforms so that users can answer those questions themselves and data teams can focus on more important topics. Previously, you would have to really understand the company documentation and go through different wikis to find out what data lived where. But now with AI assistance, you can do that all through natural language. And before, if you wanted to do some sort of advanced analysis like text classification on unstructured data, you really needed some more advanced data science skills. But now you can really easily use natural language to complete complex data analysis tasks with a single line of SQL. Now at Databricks, all of this is powered by Databricks IQ. Databricks IQ is our knowledge engine that really understands the context of your data environment to provide you good recommendations. Every company has their own set of jargon, their own definitions for what a fiscal quarter means. And what we want to do is give you answers and recommendations that work for your company. Databricks IQ does this by taking information from Unity Catalog, from your assets like dashboards, notebooks, and queries, and even looks at things like your org chart and what's popular in your organization. It takes all this information, pulls it together, and then gives you actionable recommendations on our natural language interfaces like code assistance and dashboard assistance, and our other AI-powered features across the board. So, what's inside of Databricks SQL, and how does it leverage these AI features? Well, first off, you have our SQL editor, which provides a simple yet powerful experience for querying your data. For those of you who are coming from a traditional data warehousing background, you'll be familiar with its interface, and you'll be able to use standard ANSI SQL to write your queries. The SQL editor also supports some advanced AI features like real-time autocomplete, an inline Databricks assistant, which is coming to help you answer questions inside of your query text box, and also our code assistant as well. These AI features dramatically speed up development and provide less technical users who maybe aren't always familiar with SQL with support to easily get them going. But Databricks doesn't really just stop at querying data. We're making continued investments in Lakeview dashboards, which provides a simple way to create beautiful dashboards right on top of your data. These dashboards are super easy to share with your entire organization, so you can get insights to your key stakeholders. With AI assistance, you can also create dashboards without really needing to touch SQL. Just use natural language in your mouse to be able to navigate through the environment. And coming soon, you'll also be able to embed these dashboards in different web pages and applications so that you can get insights to your stakeholders in the places that they already are. Of course, Databricks SQL also works well with your entire data ecosystem. You can really easily connect to your partners, whether they be data providers or data tools, and combine the power of the Databricks platform with the tools you already have and use. We're excited to continue to support your data ecosystem and make it easy for you to plug and play with a variety of our partners. So there's much more to cover within Databricks SQL, but that's enough talking. Let's take a quick tour of Databricks SQL so that you can see it in action for yourself. So when you launch into Databricks, you'll be greeted by this homepage, and you'll see this left navigation menu here. This section contains all of the tools you need for Databricks SQL. You'll see you have access to our SQL editor, a queries list page, the ability to access dashboards to create and share, alerts to set on top of your data, and also 2 tabs for query history and SQL warehouses, which helps you understand your past query execution on Databricks. So for the purposes of this walkthrough, I'm going to pretend that I'm an analyst who's coming into Databricks to try to pull some insights from my data. Let's say I work at a kitchen supply company, so we sell pots and pans and things like that, and I want to understand a bit about our sales, what reviews people are leaving, and things like that. So to get started, I'm going to go to this search bar up here, and I'm just going to search for kitchen. And we'll see we get some results from my search. Now this search is powered by Databricks IQ, so it understands the context of what tables exist in Databricks, any queries that have been previously written, what's popular, what's not, to give me really good contextualized recommendations. In this case, I can see I've got 3 tables. I've got a SKUs table, it's in this kitchen supply schema, and we've got some other metadata here as well. I've also got an orders table and a reviews table. Let me go ahead and click on this reviews table to open it up. This will open up inside of Catalog Explorer. On the left, I've got my catalog browser, and you can see my 3-level namespace, including other data sets within this kitchen supply schema. On the right, I can see the actual information about this reviews dataset. I can see what columns are available, primary keys, foreign keys, data types. And if I click on View Relationships, I can also get an ERD diagram that shows me how reviews relates to other tables like SKUs, which contains information about like the product name and price, and also customers. So who are my customers? What are their addresses? Things like that. So I'm going to go back, and then on the right, you'll also see more metadata about this table. I can see the owner, when it was last updated, popularity, and then down here, I also have what we call AI suggested comments. So AI suggested comments provide an easy way for me to update my table metadata to better provide other users with information about what data is in this table. In this case, it's sharing some information about reviews and what columns exist in here. I think this looks pretty good. So I'm going to go ahead and accept that comment so that now when someone else comes to this table, they'll be able to see that information and know what's going on with this information. Great. So I've got a quick overview of my data set. I'm going to go ahead and start creating a query with it. So I'll open it up in our query editor. At the top here, you'll see the SQL query box. Down here, you'll have the results grid. And then on the left, you have a couple tools. You'll have a catalog for browsing to your data. You'll have access to past executions. And you'll also have the Databricks Assistant. Now, the Databricks Assistant is our code assistant that helps you with diagnosing errors, suggesting code, and really speeds up your development workflows. So this is super, super handy to make writing SQL queries even faster. Now, looking through my data set, I've got some review data, and I can see the text of the reviews and what people have been saying about our products. Now, this is super helpful, but one thing I might want to do is categorize some of these reviews. I don't want to walk through them one by one and have to read through all of them individually. I want to pull out some trends. So how can I categorize these reviews? Well, in a previous world, I would have needed something like writing regular expressions and trying to make sure the word searches match up, or I would have had to have some data science experience so that I can do some text classification. But Databricks SQL gives me really simple AI functions so that I can really easily classify these reviews without needing some complex data pipelines. So I'm just going to go ahead and call our AI classify function. And I can point it at the review column, and I can add in certain labels that I think are relevant. So for instance, things like price, durability, heat retention, weight, sharpness, aesthetics, and we'll give that query a run. Now, this is only one AI function. We have many AI functions. You can do things like mask PII data and extract particular parts from text. So it's a really powerful feature to bring text analysis into your SQL warehouse. All right, we've got the results loaded. And on the right, we can see that we've started to categorize some of these reviews and ratings. So now that I've got it classified, there's a couple other things that I might want to do here. One thing is, you'll notice that I have a SKU ID, but I don't actually have the names of the SKUs. That'd be some helpful information to pull in here. Now, normally what I would do is I would go and I would write a join, right? Join this against the SKUs table, and that's going to give me the information I need. But I might not know how to write a join, or I might not know the details of that other table and what columns to join on. That's where the Databricks assistant can come in handy and is really helpful. So I can just ask the assistant to help me answer this question. I might ask something like, can you add the SKU name to the query here? So that's going to go ahead and give me a product name recommendation. It's going to give me a join and then give me a code snippet. So I'm going to pull this in to replace the current code, click run, and see the results. Now we've got our results pulled in, and you can see that we've joined on product name as well. So this was super simple. I didn't need to touch SQL. I didn't need to go dive through my catalog to understand what other tables I could join with. I just said, hey, I want the product name, I want the SKU name, give it to me, and it recognized that mapping and was able to create it. Now, there's a few other things I want to do. I want to give this a friendlier name. It's called AI classifier right now. So I'm going to say, give my columns friendlier names. And that's going to quickly just clean up this so that I get a friendlier name. So I'll pull that in. And now I've got friendlier names. And the last thing I want to do is I want to create a view from this, right? This is useful for me. I want to be able to return to this view over and over again. So I can write create view. And if I give it a pause, you'll see that it's actually giving me a recommendation in ghost text. This is our AI autocomplete. And it gives you recommendations as you write your queries in line so that you can really quickly develop your SQL queries. Awesome. Let me run that and it'll save my view. So now that I've saved my view, I'm going to want to go ahead and pull that into some way that I can share the data in that view and create some visual analysis. That's where our dashboarding tool comes in. So I'm going to go to new here, and I'm going to create a new dashboard. So you'll see here that I've landed on the dashboard page. We've got a layout canvas so that I can add my visualizations and block out titles and filters. And then I've got a data tab as well where I can pull in data. So let's find that view I just created. I'm going to search up kitchen, and we see we've got reviews and products here. So this is just going to pull in that data into this SQL kind of interface, and we can see that same results that I had before. Now let's go back to the canvas and add a visualization. You'll notice that there's an assistant box that pops up. I can use natural language to talk to this assistant box and get visualizations without needing to configure visualization widgets individually. So I'm going to ask it for a bar chart of, let's say, number of reviews by category. Great. And now we can see that I've got a visualization, and it's showing me the number of reviews by each category. Now, I might want to break this down further. Instead of coloring it by the review classification, let me do something like color it by the by rating. So split by rating category. And now we see that we've actually grouped it by rating category. So I can see that 1, 2-star, and 3-star reviews, so kind of bad reviews, tend to be related to durability, price, sharpness, things like that. That might be my hint that, hey, I should go investigate those topics a bit more, understand what's going on and why those things are generating bad reviews. Let me add another chart to this dashboard as well. We want more than one chart on a dashboard. I'm going to go to the data tab here. I'm going to select a table and I can search for kitchen again. And I'll pull in that information maybe on orders. Great, so I can see here I've got my orders data set, and I'll notice SKU ID again, but once again, I don't have the names of the products in here. That's something that'd be really useful to have in my analysis. So I could go to the assistant again and ask, but in this case, I'm actually going to purposely type out the manual join, and I'm going to add an error to it. That way we can see the diagnose error flow in action. So I'm going to write a join here. And I'm going to purposely add an error to this join. The error here is that SKU ID only exists on the orders table, but on the SKUs table, it doesn't exist. It's just called ID. So normally to diagnose something like this, I'd have to go back to my catalog, really dig through things, figure out where there's the mismatch. But instead, I can just click this diagnose error button right here. This is going to give me a recommendation for how I can fix the issue. Let me pull that in, run that, and you'll see that the query now completes, right? It's done the correct match on ID instead. So I'll go back to the canvas, add another visualization. And this time, let's ask it to show me something like weekly sales. The assistant's going to understand my data sets, and it's going to produce a visualization here. So I can see my weekly sales. I can also ask it to do things like break down by subcategory instead, in case I want a more granular view, right? I don't just want the high-level cookware and knives. And there we go. I've got a bit more of a detailed view here. Awesome. Let me complete this dashboard real quick. I'm going to add a title. We'll call this Kitchen Supply Sales. We'll give these two quick titles, sales per week. And we'll call this one classification of ratings. And voila, I've got a very quick dashboard that I can now use to communicate my insights. So to do that, I'm going to go ahead and publish my dashboard. And we can now see my dashboard that's published. I can then go ahead and share it to a particular user, or I can share it with my entire organization. So this means anybody in the Databricks account, including users who aren't in this workspace, can see this dashboard in a view-only way. I can also do things like schedule this to receive a regular subscription of a PDF. And I also have information on the underlying tables behind this data source so that I can do things like trace back issues that I see on this dashboard to underlying tables to see if it's a data quality issue or if it's actually something in the data. So mission accomplished. I've now got a dashboard that's easily consumable by anyone in my organization. I've quickly been able to pull some insights and now have shared those with my team. And I've done it with the help of AI assistants. I've been able to use the assistant to write my joins, diagnose my errors, and I've practically not had to write SQL myself. I've just been able to use natural language, ask some questions, get some answers, and rely on that to contextualize what data I have at my fingertips. That's made my development flow extremely, extremely simple. It means that a broader audience of users can now create queries and dashboards. Now, this was only a subset of functionality that we touched on within Databricks SQL. For instance, we walked through the SQL editor, but you could do something similar in a notebook, where if you want that iterative style of notebook development with multiple cells, you can do that on top of a SQL warehouse using the same ANSI SQL that you know and are familiar with. We also have functionality like Databricks alerts and tools to monitor your warehouses and query history in SQL warehouses. So we're really excited to continue innovating and providing features that leverage AI to make data insights available to a really wide range of users. Stay tuned for further announcements at Data and AI Summit, where we're excited to share some more new projects that we're working on. With that, our tour of Databricks SQL concludes, and I'll pass it over to Gaurav. Gaurav, take it away.
Thank you, Alex. Hi, everyone. I am Gaurav Saraf from the Databricks SQL product management team, and I'm here to talk about how we're building an AI-powered engine to maximize price and performance for your data warehouse workloads. Typically for data warehouses, there seems to be this eternal struggle between fast, easy, and cheap. You can get warehouses that do 2 of these, but not all 3. And in the end, you have to pick the knobs and you have to play with the knobs to get the trade-offs that you want between these 3 options. But what if you didn't have to do all that? What if you didn't have to make a copy of your data or create expensive indices? What if the system could learn which data is needed for your queries and anticipate what you'll do next? What if your queries could just work fast without all these knobs? And you could get a warehouse that is fast, easy, and cheap. Well, in the era of AI, we can use and leverage AI to replace these knobs to get exactly that. Typically, in a data warehouse, there are these 3 components that a database admin or an engineer have to tweak to get the most out of the warehouse. There's a data layout, there is a query engine and its settings, and lastly, there is compute. Well, each of these come with their own knobs. When it comes to data layout, users have to play with partitions or running analyze. When it comes to query engine, we have to implement expensive indices, rewrite queries, or try to guess the join hints that might result in the queries running faster. When it comes to compute, we have to predict when will my users be online in the day, so I can make sure there are enough compute availability for the workloads that will come from dashboards or ETL workloads. Well, it turns out that each of these layers also have a lot of telemetry, i.e. they emit data that can be used for AI. AI can be trained on this data to make decisions. We already know the data layout you have today, along with the query patterns of your users. We know the types of queries you're writing and how long it might take to run them the next time around. And lastly, we know the patterns of queries and workloads during the day, so we can make sure there's compute available when you need them. All of this telemetry and AI can then be used to replace the knobs using Databricks predictive optimizations. All of this is really part of the AI-powered engine that drives the best price and performance in the industry through Databricks SQL today. Now let's go deeper and look at some of the features inside each of these 3 buckets. First up is data layouts. Now, one of the big things with data layouts is partitioning. Partitioning your data provides significant performance benefits. Without partitioning, your queries would need to go through a lot more data to get the results it needs, which can be expensive. But at the same time, getting partitions right is pretty hard. Even if you manage to find the perfect partitioning strategy for your data, it won't adapt as there's new data coming in or your users are querying that same data differently. And this will then force you to reevaluate your partitioning strategy and do it again and again down the road. Liquid clustering is a new data layout technique with better performance than partitioning. Liquid utilizes telemetry from your data and the user's patterns to determine the best clustering approach and automatically makes incremental changes over time. On the chart, you can see how Liquid drives better performance, not just versus Hive-style partitioning, but also zero clustering. Liquid clustering is enabled by default, so you don't have to do anything anymore, and you can just start querying and get the best performance from your queries. Automatic statistics is another such feature. Why do table statistics matter? Well, they help produce query plans that then typically provide the best performance. Today, to do this, you have to run analyze manually to update the statistics used for your query plans. Automatic statistics removes this need to run analyze manually and collects stats both during ingest and then maintains them automatically later on. What it does, it looks at all the stats that are stale or for tables that are queried often and automatically prioritizes them to have stats updated. Thanks to automatic statistics for the TPC-DS 100 terabyte benchmark, we saw an overall query performance improvement of up to 33%. Lastly, predictive optimization solves a problem that many customers don't realize they have. Today, admins have to run various optimizations on tables manually to optimize the cost and performance of all the queries running on those tables. This could be things like optimize, vacuum, analyze, or even the liquid clustering I just mentioned previously, which can be run manually. But with predictive optimizations, we automatically perform maintenance on your Delta tables. For example, we'll run optimize on tables to improve query performance by optimizing the file sizes automatically. We'll run vacuum on tables to get rid of no longer needed files, reducing storage cost. Collectively, these ensure you get the best price performance and cost effectiveness while freeing up your time and energy to do better things. On the right-hand side, you can see that customers who are using predictive optimizations are seeing a 50% decrease in storage cost, while also seeing the queries improve by 2x. Next, let's look at the improvements in the query engine itself. Photon is our next generation query engine that we built from the ground up, all written natively in C++. The engine takes advantage of modern hardware aspects like vectorization and parallelization to achieve fantastic results. We use this to set the world record TPC-DS benchmark. Photon is also recognized as the best paper at the Sigma conference, considered the most important event in the research for database systems. In Databricks SQL, you don't have to do anything to turn on Photon. It's already there. What's the impact? You see 3 to 8x fast execution for interactive queries, 1/5 the cost for ETL workloads, and collectively, it gives you a 30% reduction in cost. Additionally, as you can see, we're constantly making improvements to Photon over time, and we expect performance to improve over time. Another feature we built using AI is predictive I/O. Many queries for reading or writing are just impacting one or a few rows. Typically, in a columnar database, this requires creating indices that can be expensive to build and maintain for data warehouse admins. Predictive I/O can triangulate where your data might be in all your Delta files for both reads and updates. The AI model can improve workloads by almost an order of magnitude without any user intervention. On the left, you can see a benchmark for reads comparing selective query performance using Databricks SQL. Predictive I/O matches a cloud data warehouse's performance with what they call search optimization services, but actually that costs a lot. And DB SQL with predictive I/O matches the same performance without any of that cost. For writes, when you have to delete a single row, similarly, we can see 6 to 10x the improvements in speed when it comes to write performance. So using AI, predictive I/O gives you the performance of an index without any manual tuning or the extra cost of an index. This is why we call it indexless indices. Finally, let's look at the features on the compute side. Databricks SQL is a serverless warehouse which brings a truly elastic environment that's instantly available and scales with your needs. You no longer have to wait for infrastructure resources to become available to run your queries, nor do you have to figure out, gosh, when in the day are my users going to come in that might see spikes in usage and provision compute accordingly. Databricks SQL Serverless uses AI to dynamically grow and shrink the resource available, so you can throw whatever workloads you have at it during any time of the day, and it'll automatically get the compute ready for you instantly the minute you need it. Another feature is intelligent workload management. We have built this to optimize the usage on top of those compute resources. Intelligent workload management automatically monitors each query being submitted, estimates the size of the query using AI, and allocates to the cluster the sufficient compute capacities. If there isn't enough compute available, it can react 5x faster and provision new compute instantly to make sure query latencies remain good. Equally importantly, when those clusters start idling, we can shut them off 5x faster to save you money. Instant serverless compute combined with intelligent workload management work really well together. By learning from your workload patterns, your query histories, and using AI on top of that, we're now seeing query performance improve by almost 3x for customers using this. Finally, let's look at the overall impact on performance and TCO of all these features. How is Databricks comparing versus all our industry peers? For BI workloads, Databricks SQL has world-class performance for high concurrency workloads. In BI, what matters most is how performance scales as more users join the platform. As you can see, Databricks SQL starts about the same when you have just a few users in the platform, but as the number of users scales, we have a 9x better performance than the leading cloud data warehouse. Similarly, for other types of workloads, Databricks SQL meets or exceeds all leading cloud data warehouses across all scales from 100 gigabytes all the way up to 30 terabytes. This is all thanks to Databricks SQL having an AI-powered engine, giving you the best price performance in the industry without needing to play with all those knobs to get you there.
네, 이렇게 3개의 세션을 살펴봤습니다. 오늘 보신 것처럼 데이터브릭스는 스토리지 레이어부터 쿼리 엔진, 그리고 컴퓨트 레이어, 사용자 인터페이스에 이르기까지 AI 기법들을 적극적으로 활용해서 성능과 생산성을 향상시키고 있고요. 비용을 절감하실 수 있도록 하고 있습니다. 기존의 레이크하우스에서 한 발짝 더 나가서 데이터 인텔리전스 플랫폼으로 진화하고 있다고 얘기할 수 있습니다. 오늘 세션이 도움이 되셨기를 바라고요. 앞으로도 저희 데이터브릭스 버추얼 이벤트 다시 보기 프로그램에 많은 관심을 부탁드립니다. 감사합니다.